How you doing, guys? We are looking at functions here. That's text and test 5, page 235, 238. We're going to look at those 6 questions in a minute. Just to start with, during this chapter, a useful page is page 23 here in your log tables, where they tell you all of these different, what natural numbers are, what integers are, rational, real, complex, just if you don't know them off the top of your head, I suppose. It's a useful page to have open. So a function is comprised of two elements, inputs and outputs. And normally we call the inputs the x values and the outputs the y values. And when we plot them out, we put outputs on the y-axis and inputs on the x-axis. Okay, so probably no surprises there. Very simple function here, y equals x squared. So a couple of ways to represent it. One is this thing called a mapping diagram, where I've said for these 5 numbers, if those are my inputs, you get 1, 4, 9, 16, 5 squared, 25 is your output. So if you're doing that, these numbers are called the domain, and these numbers, the outputs, are called the range. Another way of demonstrating that same set of numbers is on a coordinate diagram. So you see here, 1 goes with 1, 2 in gets 4 out, 3 in gets 9 out, 4 in gets 16 out, 5 in gets 25 out. Okay, so these are functions. If you were to take this and join this all up, you'd be changing the function slightly, in that you'd be saying now, rather than here, where you'd say, well, my domain is the x values, which are integers or whole numbers, and again, page 23, you'll see that, and are less than, less than 6 or less than or equal to 5, maybe. That's how you define this domain. Whereas if I join these all up, now over here, you're saying, well, those are the real numbers. That is all of the numbers between 0 and 5. Okay, so that's your domain. Equally, you define your range here as between 0 and 25. Now, sorry, a little bit more specifically. In this case here, your domain, your range is 1, 4, 9, 16, 25. All of the whole numbers between 1 and 25 is called your codomain. Okay, so your codomain here might be all of the natural numbers between less than or equal to 25. Okay, up here, your codomain would be x, that should have been y, really, shouldn't it? Or quite a lot, you'll see f of x. So f of x needs to be less than 25. Okay, and those are kind of equivalent notations. You can use either of them. Up here, we'll say f of x is less than 25, greater than or equal to 0, and it is also an element of the real numbers. So this is your codomain, but here your codomain and your range is the same set of numbers. So here your codomain is 1, 2, 3, 4, 5, 6 up as far as 25, these numbers, but your range is the actual outputs 1, 4, 9, 16, 25. So very often your range and codomain are the same, but if your range is different, then it is always a smaller set than your codomain. Your codomain is always the larger set. Okay, so yeah, I want to discuss domain, codomain, range there. Okay, so really a lot of this section is about vocabulary. Here, if you have still x as your inputs and y as your outputs, but if you're working with this rule, x equals y squared, well, 1 would give 1 squared. X would be 1 squared. This time you'd be working with your outputs really. You'd be saying 2 is y, then x needs to be 4. Y is 3, x needs to be 9. If y is 4, x needs to be 16. But what's important here is remember, these are your inputs. If you put 25 into this function, you get a 5 out. If you put 16 in, you get a 4 out. And if you plot that out, here's what it looks like. Okay, you get a 1 in gets a 1 out, a 4 in gets a 2 out, a 9 in gets a 3 out, 16 in gets 4 out, and a 25 in gets 5 out. Okay, And again, you might connect that all up, so you're talking about the real numbers rather than the integers. But what's interesting about this is if you extend your range, okay, so this is on what's called a restricted range where y has to be positive, okay? But if you ignore that, you say, well, y can be positive or negative. Let's extend this to values of y between, will I get to -5? Yeah, I probably will. And 5. Okay, I'll just extend that line a little bit. 3, 4, 5. Here's what you're going to get, roughly. Okay, you get this, which, yeah, it looks like a quadratic curve, but this is different to the ones we've seen up to now, because it's sideways. Okay, and what's interesting about this is if I, for example, decide, well, if 4 is my input, what's my output? The answer is, well, it could be 2 or it could be -2. And in that case, this function, x equals y squared, or this relationship, sorry, is not a function. And the reason is because 4, or a few elements actually, all of the elements that are positive have two outputs, okay, 2 and -2. So if one input corresponds to two outputs, then you're not talking about a function, it's just some relationship between the numbers. So in our definitions of functions, that's going to be important. So I said we'd look at question 2 to start with. This is page 235, sorry. State why the following sets of couples is not a function. Okay, so 2, 5, 2 in, 5 out, 3 in, 6 out, 5 in, 8 out, or 2 in, 10 out. Well, because 2 in gives 5 out or 2 in gives 10 out, because there are two possible outputs for 2, that's not a function. Okay, question 3, with these mapping diagrams, are each of the following mapping diagrams, do they represent a function? Give a reason for your answer in each case. Okay, so 3 in gives just one output, 4 has one output, 5 has one output, and 6 has one output. That's fine. This one, yes, it's a function. Here, A has an output at D or at E. So if you plug an A in, you don't necessarily know what you're going to get out. Okay, there's more than one answer, but that is not a function. Here, if you plug a 3 in, you're always going to get a 9 out, one output. If you plug a 5 in, you're always going to get a 9 out, one output. So that's not a problem. Plug a 7 in, it only has one output. 9 only has one. Oh, 9 has two outputs here. Okay, 9 could give you a 14 out or a 20 in. So that's not a function. Over here, P gives an A, Q gives an A, R gives an A, and S gives a C. Okay, each input has exactly one output. So that's fine. That is a function. And it's not a problem that these three inputs give the same output, as long as when you plug in a P, you know what you're going to get out. When you plug in a Q, you know what you're going to get out. Just worth pointing out over here, the range is A and C, but the codomain is A, B, C, D. So the codomain is the allowable outputs, and the range is the actual outputs. Question 6 here, given that g of x is x minus 2 squared, find g of 4, g of minus 4, g of 8, and g of a. So this is just, you know how to use the function notation, okay, which is, here's a function, plug 4 in for x into the function, what do you get out? Okay, so if you plug 4 in to x minus 2, 4 minus 2 squared is 2 squared is 4. Plug a minus 4 in, you get minus 4 minus 2 squared, which is minus 6 squared, which is 36. You plug an 8 in, you're going to get 8 minus 2 squared, okay, 8 minus 2, which is 6 squared, that's a 36. Not a problem that they're the same output. You know if you plug an 8 in, you're only going to get one output. If you plug an A in, you get A minus 2 squared. So g of A is A minus 2 squared. Square the first, square the second, twice the product is minus 4a. Question 8. You've got this function f of x, which is 4x, and this function g of x, which is x minus 2. So this is just slightly different notation for functions. And it means the same thing as f bracket x equals 4x, or g bracket x equals x plus 2. Just different notation that they want you to get used to. If g of 3 plus k times f of 3 equals 8, find the value of k. Well, g of 3 is going to be 3 plus 1. That's 4 plus k times f of 3 is 4 times 3 is 12 equals 8. So they just want you to solve that. Move the 4 over, you get 12. K equals 8, take away 4 is 4. And k is 4 over 12, which is 1/3. Question 14 asks us to use the vertical line test to determine if each of the following is the graph of a function where x is a real number. Now, the vertical line test we haven't talked about, but if you come back to that first page, you can see here that even if I've extended this to its full kind of quadratic, any vertical line I draw crosses the graph exactly once. And that tells me that each input has only one output. Okay, so the vertical line test is a way of saying, is this a function? Here, any vertical line I draw crosses the graph twice, then that's a problem. The vertical line is not allowed to cross the graph twice because that suggests if that's, I don't know, a 9, yeah, if that's a 9, that there are two possible outputs when you plug a 9 into this function, and that's a problem. So you don't want to have that. So a vertical line test. By the way, here, if I said x equals y squared and y has to be positive, well, now I'm ignoring all of this. That's called restricting your range. And by restricting your range, you can take something that's not a function and turn it into a function. So that there is a function. That's acceptable. Question 14 anyway, using our vertical line test. Is this a function? Yes, it is. Okay, no vertical line crosses more than once. Okay, all three of the first ones, they're all functions because no vertical line crosses more than once. Whereas here, this vertical line here crosses twice. So that is not a function. This one, now circles, generally speaking, if you were given x squared plus y squared equals 9, which is the function, the formula for that circle, you do not have a function. But because they have restricted the range, they've said this is only positive answers, then you do have a function, okay? There's no vertical line that crosses more than once. This one, what do you think? Yes, not a function. This one is a function. This one is a function. This one, not a function, crosses here and crosses here. Okay, so if a vertical line crosses twice, it is not a function. Last question we'll look at here, question 16. State the domain and range for the relations represented by each of the following graphs. Okay, so the domain is the allowable inputs, the range is the allowable outputs, or the set of outputs. So the set of inputs here goes from minus infinity all the way to plus infinity. Okay, that's what that continuous kind of bar shows. These ones here where there's a dot means it starts and finishes at a particular point. Here, and then your range is from -2 up to infinity. Okay, so you might write that as -2 comma infinity, or you might write that y needs to be greater than -2 and an element of the real numbers. Okay, so there's more than one way to write these answers. Give me a second, I'll check the back. Okay, so the back is using this type of notation here, so I'm going to stick with that. Just to show you, the square bracket means -2 is an allowable value. The round bracket means infinity is not an allowable value. So this is kind of similar to saying y needs to be greater than or equal to -2, but it has to be less than infinity. Okay, obviously it can't be equal to infinity. Okay, the next one here, the input values are anything up as far as 2, you can plug into this function. Anything above 2 isn't going to work. Sorry, for these relations, because this one is not a function. But you would have to say the domain is between -infinity and 2. The range seems to be plus to minus infinity. Oh, curly bracket, -infinity, plus infinity. Okay, and I should have had a curly bracket over here as well. Here, your inputs are between -2 and 3. Okay, that's what the dots mean, you don't go any further. So that's -2, 3, that's your domain. And your range is from 0 up to 9. Okay, domain. range. Sorry now to be making such a mess. Hopefully you can do a tidier version in your copies. Here, again, your inputs are between -3 and 1 are the only allowable inputs. So that's your domain. And your range, your outputs are between -6 and 2. That's your range. Inputs here are between, well, that's the circle of radius 2, so that comes out to 4. So between -4 and 0, those are your inputs. That's your domain. Your outputs, or your range, is from 0 to 4 as well. And over here, your inputs are any of the real numbers, but your outputs are all of the y values less than 4. Okay, 4 is not an allowable value, so 4 gets a curly bracket because it's less than 4, but you can't use it. And that goes down as far as minus infinity. Okay, so there's 16. What I'd like you to do now, please, is on page, well, on that same set of exercises, question 2, 3, 5, and 15. Okay,